Hello everyone, here are the solutions worked out for problems 9 through 15 off of yesterday's worksheet. So remember, all of these still are under the directions to assume no denominator is equal to 0, which means we don't have to state restrictions, but we do have to show our work. So for number 9, we need to start by factoring. We do not cross anything out until we factor. So this first numerator, there's no GCF. We're going to factor in 2 sets of parentheses. First, we're going to have x and x. What's going to help us here for 6 is 2 and 3. Everything's positive, so plus 3 plus 2. In our denominator, there's a GCF of 3. What's left is the quantity x plus 4. There's a GCF of the second numerator. There's an x. What's left? X plus 4. And then I'm just going to keep the bottom denominator there, the second denominator rather, in parentheses. There's nothing to factor. Now we just go through and cross out. So I notice the x plus 4s are going to cross out. The x plus 3s are going to cross out, and that's it. So what do we have left? Up top, I'm going to write the x first. X times the quantity x plus 2 all over 3. All right, for number 10, it looks more complicated, but it's actually the simplest problem on this whole worksheet. If you notice, we have pretty much the same thing that we're dividing, except one's negative. So guess what? These are opposites. Or we could just rewrite this as multiplying. We take the first fraction, we keep it the same, and we multiply by the reciprocal of the other fraction. So now the x to the 3r's cross out, m's cross out, and as everything crosses out, we're not left with zeros, but we're left with ones. So because I have a negative here, when I divide opposites, or when I cross everything out, I'm left with a negative 1. All right, for number 11, this x cubed minus 8, that is a difference of cubes. So we did this the other day in class. We're going to make this will always factor into a binomial, then a trinomial. What goes in that binomial is the cubed root of each term, so that's going to be an x and a 2. Remember, we follow SOAP for the signs, so I'll have a minus. Then I square the x. X times x is x squared. Opposite sign, so plus. Then I multiply x times 2 in the middle. And then always positive at the end, and 2 times 2 is 4. X cubed minus 4x, there is a GCF of x. And we're left with x squared minus 4. Second numerator, there's a GCF of x squared. We're left with x plus 2. And I cannot factor that denominator, but if you notice, that numerator, that trinomial, matches perfectly. So even if they did factor, we wouldn't need to. If they match perfectly, why do any more work? All right, what I can do, if you wanted to, we could cross out this stuff so we don't have to keep writing it. I can cross this out, and I can cross this out for right now. So what I have left up top is still x minus 2. I have to rewrite it because now my x squared minus 4 could still be factored. So I'm going to write that, factor that as an x minus 2, x plus 2. What could also help is I could write this x squared as just x times x plus 2, and then technically that's over a 1. So now more stuff crosses out. X minus 2's cross out. X plus 2's cross out. This x can cross out with 1x here. So everything crosses out except for one more x. Okay, number 12. Hopefully you found this one to be pretty simple. X squared minus 1 is a difference of squares, so that factors into x minus 1, x plus 1. There's nothing I could do with the 16x. The 4x squared, if it helps, I could write it as 4 times x times x. 5x plus 5 has a GCF of 5. What's left? X plus 1. What crosses out? X plus 1s. 4 can go into 16, so 4 becomes a 1, 16 becomes a 4, and then this x can cross out with 1x up there. So what do we have left? Up top we have an x times a quantity x minus 1. In our denominator we have a 4 times 5, so that would give us 20. All right, 13. This one had a very strange looking answer. There's not much that crossed out, but again, we're going to first take a look. We are dividing, so my first step is not to factor anything, but to multiply by the reciprocal. So we have 2n squared plus 5n minus 3 over n plus 2 times 9n plus 8 over 1 minus 2n. So really the only thing that factors is that numerator. There's no GCF, so I'm going to make 2 sets of parentheses. The only way to factor 2n squared is 2n times n. I'm going to try 3 and then a 1 here. So I am going to get a 6n on the outside and a 1n on the inside. My signs need to be different, and I need to end up with a positive 5n. So I'm going to put the plus here. That gives me a positive 6n minus a 1n is a positive 5, and then I still get my negative 3 at the end. Then I have it over n plus 2. There's nothing I could do with the 9n plus 8, but I'll leave it in parentheses. And there's nothing I could really do with the 1 minus 2n. So now if we take a look, we have a 2n minus 1 and a 1 minus 2n. They're not identical, so then the next question is, are they opposites? Yes, the 2n's positive here, it's negative here. The 1 is negative here, it's positive here. So as we divide opposites, we're left with a negative 1. So this is my final answer. I just have a negative sign in front. I've got the quantity n plus 3 times the quantity 9n plus 8 all over n plus 2. All right, for 14, quite a bit factored here. But again, first we're dividing, so we want to rewrite this as a multiplication problem. So we have c to the 4th minus d to the 4th over 5c minus 5d times 5 over c squared plus d squared. Now we're ready to factor. C to the 4th minus d to the 4th is another difference of squares. It factors into c squared minus d squared, and then times c squared plus d squared. Square root of c to the 4th is c squared. Square root of d to the 4th is d squared. 1 plus 1 minus. But guess what? That c squared minus d squared is going to factor again. I could factor out a GCF of 5 in that denominator, c minus d. Nothing I can do with the 5 here, and there's nothing I could do with c squared plus d squared. In fact, what we could do with it now is they match here, so I could just cross them out so I don't have to keep rewriting them. Now I'm going to factor the c squared minus d squared, so that factors into c minus d, so it's another difference of squares, c plus d, all over 5 times c minus d, and then this is just times 5 over 1. So we still cross out, we could cross the 5's out, that's nice, cross out the c minus d's, and we are left with c plus d. All right, and then our last example, again we're dividing, so I just want to rewrite this as y. We're not flipping that one yet. So we have y over x minus y times y minus x over x. So my binomials, just to make them look together, I'm going to keep them in parentheses. Now I can't really factor anything, and if you notice I have an x minus y and then a y minus x, and again those are what? They're not perfect matches, but they are opposites. When I cross them out, I just have a negative 1 left. So I could really write this as a negative y over x, or it could be a negative out in front, or we could have y over negative x. All of these mean the same thing, but here's our answer. All right, so as always, guys, let me know if you have questions, especially after you watch this. You will have your team quiz today, so use these problems to help you through that.